Good morning. At least it's morning for me. Beautiful sunny day. I hope everybody is well. And um, today we are going to talk about PageRank. Very interesting topic, very mathematical, but our discussion is going to be very informal. Um, Couple of things about PageRank. PageRank was based on some work by Brin and Page. Um, this might have an I in it. These are the guys that founded Google. And this was all based on a paper that they wrote while they were both graduate students at Stanford. They were working on their PhDs. They never finished them. I'm not sure they ever finished their master's degrees, but they did go ahead and they started Google. And a lot of what Google is based on is this thing called PageRank. I do want to say right here at the beginning, Google employs many different ways of evaluating web pages, not only PageRank, but PageRank was something different than anyone had thought about before then. We've already looked at the vector space model, and we've noted that with the vector space model, that this is basically, has to do with the content of a page. In other words, what happens in the vector space model is we go ahead and we look at the actual words that comprise a particular document, and somehow the measure of the goodness of that document is based upon the content of that document. PageRank doesn't look at the document at all, or I should be careful there. It does look at the document, but it's not concerned about the actual words that are employed. Rather, PageRank is a voting system. Okay, in other words, PageRank is something that's based on popularity. And the question is who gets to vote? And the answer is everyone. Pretty remarkable idea. Okay, so instead of getting really carried away in lots of bad mathematics, let's get carried away in some simple mathematics, and let's just consider a test case of how PageRank is going to work. So I'm going to come up with a very simple picture of a corpus of documents. So here is document A, and here is document B. And over here is document C. And over here is document D. Okay, now recall we said that in PageRank, who gets to vote? Everyone gets to vote. And what is a vote? A vote is a link. So I want you to imagine over here that document A contains a link to B, and it contains a link to C, and it contains a link to D. Let us suppose that B links to A, and B links to C. Let us suppose that C links back to B, and let us suppose that D links to C, and D links to A. Okay, so the first thing to say is that in the PageRank system, if you're a document and nobody links to you, you don't get any votes, which is another way of saying that if somebody searches, it's very unlikely that that document's going to come up. On the other hand, if there are a lot of links pointing to a particular document, that's going to be good. Because here's what's going to happen. It turns out that PageRank is a number, and Google has decided it's a number that's between 0 and 10. And the actual quantity does correspond to something that we're not going to be very interested in right now. But here's another interesting thing that I want to show you. So let's suppose that initially, well, first of all, I want to notice the following in this. Let us suppose that A has a page rank of 5. In fact, why don't we suppose that all of these pages have a page rank of 5? Now, the fact that A has 3 links going out means it's going to send a third of its page rank to each one of these. So this is going to be, this link over here is initially worth 5/3, and this is worth 5/3, and this one over here is worth 5/3. So first of all, when I want to come over here, I want to say that B's page rank is equal to 1/3 of A. Likewise, C's page rank is equal to 1/3 of A. And D's page rank is also equal to 1/3 of A. Now, we're not done here, because now B has a page rank of 5, and it has 2 links going out. So what's going on here is if there are 2 links going out, it's going to send half of it back to A, and it's going to send half of it over to C. So A is equal to 1/2 of B, and C also gets 1/2 of B. All right. Now C over here, we can see that C only has 1 link going out. Okay, so that means that what's going to happen up here is that this is all going to get shipped back up here. This whole link, this one out link that C has, is worth the entire thing. So over here, I would say this is plus C, and the 5 goes over here. Over here, we can see that D has 2 outlinks, so that 5 is going to be split between these 2. So a 5/2 goes this way, and a 5/2 goes that way, and this is going to be plus 1/2 of D, and this over here is going to be plus 1/2 of D. Now the thing is you can see that what is going to happen is that's going to update these values, but it's going to keep updating them. In other words, there's not just one update, it keeps happening over and over again. So there are a couple of issues that I want to bring up here, and we're going to give you a demonstration in 1 second. I'm going to demonstrate to you that these initial values really were meaningless. Okay, we're going to see that they're going to converge to new values after we go through this recurrence relation over and over and over again. So to do that, lo and behold, we're going to use a spreadsheet. And what I'm going to do is I'm going to come over here, and we're going to do a few things here. So first of all, I'm going to call this A, B, C, and D. And initially, I'm going to come over here and I'm going to give these all the value 5. Now, over here, we see that A should be updated with half of the value of B. Now, remember, this is B over here. All right, so that's B4. And then 1/2 of D, and that's B6. So I'm going to come over here and I'm going to say that is equal to 0.5 times B4 plus 0.5 times D, well, D is B6. Okay, so that just came back to 5. We're not done with that yet. Let's come over here. B is equal to 1/3 of A, so that is equal to times, and A is the cell B3, plus, and now I have to add the cell C, which is B5, and that got updated. And now I have to figure out what is cell C. Cell C is equal to 0.33333 times cell A is B3 plus 1/2 of B, so that is 0.5 times, and B is B4 plus, and now I have to do 1/2 of D, so that's 0.5 times cell D is B6. And then I come over here to D, and that is equal to 0.33333 times the cell of A, which is B3. Okay, well, now let's focus in on the spreadsheet for a second. Now I want you to notice something. First of all, if I come over here and I go the sum of B3 to B6, it's 20. But here's an interesting thing. I'm going to copy that formula next door, and you'll notice it's 19.99995. It's 20. If you sit and do the math, you're going to see that the total page rank in the system doesn't change. But now, here's the thing that I want you to appreciate. If I keep calculating this over and over again, and I'm going to say copy, and let's move this way out here. Let's go out to there. Okay? So first of all, I want you to look at the sum. And we can see the sum is 20, okay? It turns out that with each iteration of this, it gets to 20. And the other thing I want you to notice is I want you to notice that the numbers are sort of, you can see they're starting to converge. And here's something interesting I want to show you. I'm going to copy this column over. So I've got 4.58617. I know you're all laughing at me because I should just go ahead and copy it. 7256, and I get 6.1368, and I come over here and I get 1.5506. Okay, so this is just a copy of the page rank here. After how many times did I recalculate? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. But now I'm going to come over here and I'm going to change these numbers. And again, I'm going to let the page rank total 20, but I'm going to pick different numbers. So what about if I went 64645? And you'll come over here and you'll notice that these numbers are still remarkably close. Well, let's change the numbers even more. 7, 3. And if you come over here, you'll see that these numbers here are still very close to this. Let's make them really different. Let's come over here and let's make this 13. Let's make that 7. Let's make, well, that's, I want them to add up to 20. Let's make that 13, 1, 2, 4. Okay, it still adds up to 20. And you'll notice over here that these numbers all appear to be very close to this. Okay. Now what's going on here, there's a mathematical proof of this, that it doesn't matter what four numbers I put here, that if I go ahead and, whoops, somehow some bad numbers got put in here. There we go. That if whatever numbers I put in here that add up to 20, let's really make it bad. What happens if I come over here and I do 18, 2, 0.5, and you come over here, you can see that these numbers are still really close. And if I took this iterations out, I did it 13 times. If I do it to about 20 times, it's going to get, you're going to see very, very little difference from one column to the next. Now, I hope you're understanding what's going on here is I've got a recurrence relation here. Okay, so that I have to keep cycling around here before I'm going to get convergence. But I, in fact, do get convergence. And you'll notice over here, so these would become the updated page ranks. So that if I were to start off with these page ranks here of 5, that we're going to see that eventually what's going to happen is this one over here is going to change to 4.6. This one over here is going to change to approximately 7.6. This one over here, that's D, that's going to change to 1.5. C is going to change to 6.1. Okay. And I think to some extent these results shouldn't be surprising. This one only has one link to it. Okay. This has multiple links to it. This has multiple links to it. So these all stayed up there in the 5, 6, 7 range. This one went down quite a bit because there wasn't that much pointing to it. So the idea of PageRank is that it is this iterative calculation. It's not something that you just do one time. I think Google typically does it 20 times. And if we were to carry this out to 20 times, we would see that these numbers would vary very little. There are a couple of other things that need to be said about PageRank. Let me just get the spreadsheet out of the way there. So when we calculate the page rank of some page at time t, if you go back and you look at the original paper, they say what you want to do is you want to have it be D times the page rank of P at t minus 1 plus 1 minus D times, and I'm going to come over here and I'm just going to call it the page rank calcs, which we just did here. And the idea here is that D is some number between 0 and 1. And in fact, what they typically do, I think if you read in the paper, they'll say something like D is typically set to about 0.85. So that this is 0.85, this is 0.15. And you can think about what this means. What they're trying to do is they're trying to say they don't want the page rank to change too much from one calculation to another. Okay, so that this will be whatever the page rank was last time, and this is whatever the page rank is after doing these calculations. So that in fact, if we were to use that value, if we came over here, for example, and we look at A, well, A's page rank, so we would go 0.85 times, and I'm going to go back, A originally had a page rank of 5, and then it's saying it recalculated to be 0.46, and we can see what that would be. I can't believe this, but I'm looking for my calculator. I know I've got one here someplace. Calculator. So I come over here, so it is, and this is a weird calculator. I want a basic calculator, and I want it to be 0.85 times 5 is equal to, and that's 4.25. So I'm going to say plus 0.15 times 4.6. And that's equal to 4.94. So you can see that there wasn't much variation from here. I hope there's not confusion in what's going on here between these subscripts. These subscripts over here Remember this, what I am demonstrating right here, this is the recalculation of the page rank for one generation, okay? These subscripts over here in the T, these are referring to a generation. So in other words, the difference between this right here and this right here was all of these calculations that happened here in this spreadsheet. I hope that is clear. There is a paper that you can reference on this. But the other thing that I want to note here is again, remember that this is basically, this is based on voting. Okay, this is voting, not word content. And that's a very important thing to keep in mind. That's it for now.